Hello, Legacy students. Marsh here. So today we're going to talk about the converse of the Pythagorean theorem, aka the inverse of it. So what can we say about the Pythagorean theorem and use it? You're going to want notes, calculator, just to do some squares, and then pen or pencil today as well. So basically the focus of today is what kind of triangle am I? Basically the converse of the Pythagorean theorem allows us to see what kind of triangle we actually have. So what makes a right triangle a right triangle? Well, basically you need to know if it's a right angle. Now sometimes you're not going to have it marked in. You need to figure out, is it a right triangle or not? Well, ultimately what you can use is the Pythagorean theorem. If the two legs, what would be considered the two legs, added with their squares, added together, equals what would be the hypotenuse, or the longest leg, squared. That will allow me to see if they are if this is a right triangle. Let's go ahead and check this triangle here. So I know that these would be the two legs, so aka A and B have to be 12 and 16. C, what would be considered our hypotenuse if this is the Pythagorean theorem, needs to always be the longest side. So let's go ahead and figure out to see, is this in fact equal, or is this side greater, or is this side greater? So 12 squared, that is 144. 16 squared is 256. And 20 squared, that's 400. Let's add these two together. I am going to get 400. So 400 does in fact equal 400. So this triangle is in fact a right triangle. Now, what if that's not going to be right? What kind is it? You will have an obtuse triangle if the hypotenuse number, the c squared, is going to be too big. Or the acute is when your hypotenuse number is too small. So let's try a couple of examples here. I got a triangle with the sides of 8, 18, and 24. I know that the two legs are the two smaller sides. So 8 and 18, C is 24. Let's see what we're going to get. So we got 8 squared plus 18 squared has to be something to 24 squared. I'm just going to put an equal sign, that way we can kind of keep it. So I know 8 squared is 64, 18 squared is 324, 24 squared is 576. Alright, let's add the other side together. So I'll get 388 on the left-hand side equals 576. Well, they're not equal. So it looks like what would be considered the hypotenuse side, this guy, is bigger than 388. So this triangle is not a right, not an acute, but he's an obtuse triangle, because the other two sides basically have had to stretch out to be able to fit the entire hypotenuse side between the two of them. Let's try another example. So I got sides of 12.3, 16.4, and 20.5. So let's go ahead and set up our Pythagorean theorem. Oops, forgot to square. Alright, 12.3 squared is 151.29. I am going to keep decimal points. 16.4 squared, that is 268.96. And then 20.5 squared is 420.25. So I have squared all my sides. Let's figure out what that left-hand side is when I add. That is 420.25. Ooh, look guys, they are equal, which means if they are equal, we have a right triangle. And the final example of the video today. Oh, ooh, this guy looks kind of funky. But don't worry about him. He's just a number. So 4 squared plus, I'm going to put that piece in parentheses. There we go. Equals 8 squared. So 4 squared, I know that to be 16. Now, let's talk about that piece over here. So 4 square root of 3 squared. Technically, all that is 4 square root of 3 times 4 square root of 3, because that's what squared means, multiply by itself. So what we're going to do is multiply each piece by itself. So 4 times 4, that's 16. Square root of 3 times the square root of 3, that's technically the square root of 9. Which, square root of 9 is just 3, so this is technically 16 times 3, which is just 48. So technically 4 square root of 3 squared is just 48. So basically all I did is I multiplied the two outsides, multiplied the two other ones, and then multiplied it all together ultimately. 8 squared, that is 64. 16 plus 48 is 64 as well. We got a right triangle. And that's the end of this video. See you later, Sabers.